Hi, I'm Edoardo. I'm 18 and I'm Italian. And I'm here to talk about a topic that we can find everywhere in our everyday life. A topic that we could call reason. In fact, it moved its first steps in the second half of the 19th century. But a topic that is a crucial point nowadays for the social studies, the statistics. The statistic, or descriptive statistics, analyzes with mathematical tools a big bunch of data incoming from studies, polls, or either interviews conducted on the population, that is, the dataset of the elements studied. Sometimes statistics study only a part of the entire population, that is called sample. Let's start with an example. A teacher, after a test, could want to compare with his colleagues the scores his students got. But he has 25 different marks, from 1 to 10, like in Italy, and he has to find an average to describe these marks. How can he find an average? Well, in statistics, average is not a precise word, just as flower for a florist. So, they are called measures of central tendency, and they are different. There is the mode, that is simply the element most studied in the dataset. In this case, is 8. But this is surely a too high average for this class. In fact, more than half scored less than the 80% of or 8. Rather, 3 scored the half. So, we need to use something else. So, there are other mathematical tools we can study with. The median, for example, takes the middle value in the dataset after we arrange data in ascending order. In this case, it is 6. But there are some teachers that tell the class, well, half of you is under the average, so you should study harder, while the other half is over. Good. But these teachers use as the average the median, so it's obvious that half will be under and the other half over. For these and other reasons, mathematicians use often the measure of central tendency par excellence, the mean, or arithmetic mean. This is its symbol, mu, a Greek letter. And the mean, or arithmetic mean, is equal to the sum of all the elements of the population over the numbers of elements in the population. And in this case, it is 6.72. We reached, finally, a good average for these test scores. But what if the teacher doesn't want to exclude the guy who scored 10 in this test? Or all the other situations where measures of central tendency are not good for our purposes? Well, for this, there are measures of dispersion, like the range. The range, in fact, is useful only when we have 2, 3 or 4 values, or when they spread around 2 values, like 8, 8, 8, 9, 9, 9. But in this case, with 6 and a measure of central tendency like the mode, we can only identify 4 and 10, while all the other values are not good defined by the range. So there is the measure of dispersion per excellence, the standard deviation. But the journey for the standard deviation is a bit longer. Let's think, always on the example of the teacher, about somehow to describe the dispersion of the data. We can, for example, take the difference between every element of the data set and a central point like the median 4 minus 8, 4 minus 8, 8 is the median, 4, 4, 4, etc., etc., 9, 9, 9, 10 are the elements of the data set, or another central point like the mean, with the mean, okay, 4 minus 6.72, 4 minus 6.72, etc., 9 minus 6.72, etc. So, and then we can find the absolute value of every difference to avoid negative values, and the absolute value that takes only the positive value of a number. And then we can find again, in this case, the median, that is 2, as you see before, and in this case is 1.55. This is called average absolute deviation. Mathematicians found that squaring the differences instead of taking the absolute value would have been more useful. So they squared the differences and then they took the mean of the differences. They invented the variance. But also variance has a problem. In fact, if our values have a unity measure, the variance will be in that unity measure but squared. So, what is it? We can take the square root of the variance, and this is our standard deviation. Standard deviation. Yeah. Its symbol is sigma, another Greek letter. Sigma stands for standard deviation. And it is our measure of dispersion par excellence. Finally, our teacher found the measures par excellence to describe his test: the standard deviation for the dispersion and the mean or arithmetic mean for the central tendency. But what if he wants to compare the variation of the test with the variation of the weight of a bunch of cows? Well, there is the coefficient of variation. Or CV. It is simply the CV, sigma, the standard deviation over the mean. And the CV is a dimensionless number, so we can compare different CVs also if they come from interviews, poll, reviews, bunch of cows, or tests. Now I'm ending this talk with a few words on a graph, the normal distribution or bell curve. It is the most common and also most popular curve in statistics. It is a histogram with the different values on the horizontal axis and the number they appear on the vertical axis. And it's useful, for example, to show different weights of a package of sugar of 1 kilo. Yeah, because a package of sugar of 1 kilo does not always weigh 1 kilo. Sometimes it weighs 1 kilo, but others less and less and less, or more and more and more and more, blah blah. This curve that sometimes we show with a line has particular properties. In fact, we can draw it only with two values. Guess what? The mean and the standard deviation. This is the mean, and standard deviation is used with computers to draw the dispersion of the data on the right and on the left. Remember that standard deviation, I didn't tell you how they show the dispersion of data. Now, with the bell curve or normal distribution, I'll show you. In fact, the 68% of the bell curve, and this is the 68%, is contained within the mean plus or minus one standard deviation. This is the mean minus one standard deviation, and this is the mean plus one standard deviation, the 68%. The 95% is contained within 95% contained within the mean plus or minus two standard deviation. And the 99.7% is contained within the mean plus or minus 3 standard deviation. There are still so many different things to speak about. Statistics is a huge branch of mathematics, but I have limited time. Hope you enjoyed, and hope I haven't made too many mistakes. All in all, English is not my native language. Bye bye.